interfaces. And I am a big fan of SpongeBob, and this rainbow definitely just reminded me of this episode, so had to add it. All right, so some people might say, as a designer, why should I know anything about code? And I think this quote from Aaron Walter is a really good explanation of why, as designers, we should know at least a little bit about the properties of code. So he says, an architect would understand the properties of concrete, so why wouldn't a designer understand the properties of code? And I think this is really great just to say, as designers, maybe we're not ever going to be the ones actually building the user interfaces or writing the back-end code. We can understand how it works and understand the tools and kind of like the history of software engineering, and it's going to make us better designers. All right, so let's talk about my design to software engineering journey. So I am a software engineer. I'm a front-end software engineer, and we'll get into what that means exactly. But I'm also a designer. So in my current role, I have like a dual title where I am a visual designer and a software engineer. And so a little about me. I learned print design in high school and college. This is a photo of me in college. I was on a magazine, a literary magazine like team, and we published this literary magazine. This was like at the launch day in Denver. I got my undergraduate degree in communication and Spanish. So I don't even have a design degree. The university I went to did not have design as a degree. I didn't even know what I wanted to do in college. So I went for communication and Spanish. And I took a lot of like designy classes outside of my majors, but just to show you that I'm not a computer scientist. And then it wasn't until 2018, so this is 4 years after after I graduated with my undergrad degree, I took a 10-week full stack software engineering bootcamp in my hometown. So it was full time. This is when I first actually started to write code. So my motivation, number one, I was looking for design jobs in my area, but there just weren't very many, and there were a lot more tech jobs. So that was kind of my first motivation. Secondly, I just knew that I wanted to build things and not just design them. I've always loved making things. Like arts and crafts was always my favorite activity in school and growing up. So a lot of the design jobs that I found, I just knew that I wanted to be involved in like making and building different software applications. And then lastly, and probably the most important one, is just that I had a few friends who learned to code and they really encouraged me. I think this is always going to be like the most important part of any new endeavor or learning journey, is having people around you who can encourage you and also who know, who've been there before. So I would love to know in the chat if you could just post what are your motivations for learning more about software? Nice. Want to build things, it's fun. Better designs, understanding the challenges and limitations of developers I work with. I think that's a really good one. Like being able to understand like where the software, like when they're talking to you about a limitation, like is what they're saying based in any reality. Sometimes I have noticed like software engineers will just lie because they don't want to build something. And it's good to know as a designer, like when that is happening. Awesome. Yes, design your portfolio. I think that's such a fun one. I love building like my personal website. I think it's one of my favorite activities. Awesome. Oh yeah, computer science classes in college being hard. I never took any, but I can imagine that I would have had the same experience. Yeah, awesome. Thanks so much, everyone. So I said previously, I'm a front-end software engineer. What does that mean? So in order to explain that, we have to go a little bit into like application architecture and like how software is built. So if we have this kind of like stack of an application, we start with like the web browser in this case, or like the front end is basically the user interface, and that is the front end, or we call it the client side. So if you see anybody like talking about the client side or the front end, that's what we're talking about. That's where I spend most of my time as a software engineer. And then all of these things in the back, the database, the application, and the server are known as the backend or the server side. So we'll go through each of these briefly. The backend has a database, and that is where we organize and persist data. We'll talk more about what a database is in a few slides. Some examples of this are Postgres, MongoDB, Firebase Cloud Store, Redis. These are all just like different technologies that allow you to like easily make a database if you're building an application. Then we have the application. This is what is listening for requests, retrieves information from the database, and sends a response. This is basically like communicating between the database and the server. An example of some of the languages you might use in this part of the stack are Python, Go, Node, C, we have C++, C#, PHP, Ruby, Java. There's so many languages here. We'll talk about why in a second. And then we have the server, which is the computer that is receiving requests. Some really common examples of this are Nginx and Apache. There are lots of other servers as well, but I think these are the two. These two are the most popular. A lot of the web is like runs on these servers. And then the web browser. So this is anything that sends requests to the back end. You know, in some instances, it's not a web browser. You might be building applications that don't have like a front end that is a web browser. But for this talk, we're going to be talking about like the front end as like the web browser building web applications. So an example of these software solutions are JavaScript, HTML, CSS, and then there's some other front end frameworks that we won't really get into. All right. I see in the chat, this is way too fast. Don't worry, we're going to talk about all of these more in depth, but we just had to kind of get into like the difference between the back end and the front end. A lot of this, you know, we could spend hours talking about each one of these things, and I want to make sure that you all are getting a good feel for just like a general how software engineering works. Yes, and definitely understanding what is happening in the back end is super important, and we will get into that. All right, so I love this meme that sort of was circulating a couple years ago of like what a full stack developer is. So the joke is that like anyone who says that they are good at all of these is a full stack developer. And there are positions, a lot of positions out there that are looking for full stack developers. And the joke here is that you say you're a full stack developer, but you're really good at the back end. You're not so good on the front end, but you know, you market yourself as full stack. And I think, you know, it's really okay to say you're full stack when you have a strength in one area or another. I consider myself full stack, but I definitely have more experience and I'm really good at the front end. Let's talk about why there are so many languages. So this slide has some logos for like some popular software languages, programming languages. And I would love to know, because we're designers and creatives, I find that designers and creatives have a lot of opinions about logos. So which logo is your favorite? Before we talk about why there are so many, I really want to know. Yeah, Lisp is a really good logo. The Lisp logo, I think, was like crowdsourced by a bunch of contributors at one point a few years ago. They didn't have a logo, and a bunch of people in the community were like, let's make one up. And they combined these little drawings. So I think it's funny. Yeah, some of these you probably might not even know the names because they like don't have the names on them. This like R with the kind of gear, that's Rust. This like, it looks like an upside down Y is Haskell. And then like, yeah, this is C, C++, and C# are these like hexagons. Yeah, so I think that like my favorite part about this is that as a designer, I always have a lot of opinions about logos. Yes, yellow and blue snakes, that's Python. It's one of the most popular languages. Yeah, as designers, we tend to have like opinions about logos. I know I do. I look at some of these and I'm like the Java logo, and I'm like, oh my gosh, what are we doing? Why was this logo made so long ago and never updated? But at the same time, you love it for that reason. So yeah, we have a lot of opinions about logos, and programmers have a lot of opinions about software languages. And really, it's just because as a programmer, you start to like use one a lot and you start to like either love things about it or hate things about it. And that's kind of why there's like a lot of opinions. There's never a right or a wrong reason to like or dislike a programming language. It's kind of just like based on your preference. But the answer to why there are so many languages is that each one has a specific like use case as to why you would use it to solve a certain problem. So you wouldn't use a bike to pick up a refrigerator. You probably wouldn't use Julia to solve a data science problem. So if you're have a lot of data that you're kind of like trying to filter through and make meaning out of, you would probably use Python or R, because those were languages that are sort of made for data science. Python is now used for a lot of different things, not just data science, but data science is one of the languages that Python is really good for, and R, which is like this blue R with the little gray oval. So yeah, that's basically the reason why we have so many. People like to develop languages. Software engineers like to develop languages to solve a specific problem. It also feels cool to write your own language. I'm not someone who's that interested in writing my own language, but there are a lot of programmers out there who are. Okay, let's talk a little bit about the front end and how there are kind of these three technologies on the front end that kind of make up what like a web browser is displaying. These might be familiar to you, but I wanted to cover them anyway. So we have HTML, which is sort of like the outline or like the bones of your front end. So this is stands for Hypertext Markup Language, and it is the core of every website. It contains every element a page contains, like images, paragraphs, titles. And then we have the CSS, which is basically adding the styles to that. So the CSS stands for Cascading Style Sheet, and it's used for adding colors, layout, and positioning elements on a web page. And then JavaScript. It is not the same as Java. Java is a different language. And JavaScript makes your websites interactive. So it is used to validate forms before submitting, to animate things like slideshows, and to fetch data from the backend. And we will talk about fetching data from the backend. Yes, so Figma devs using WebGL and C++ for their web front end. It is totally possible to use the technologies now on the front end. It's pretty cool. Yeah, at the end of the day, it's all going to compile to HTML and CSS, but yeah, there's some tools that make it really easy to like use backend technologies on the front end. All right, so let's talk about like what these things, HTML, CSS, and JavaScript mean in terms of like a real application. So I built this application about a year ago, and it's a really simple web app that just displays reflection questions or like prompts for journaling. And it displays like the question, and then below it, it displays the attribution, so who wrote that quote. So I gathered a bunch of quotes. I'd just like been collecting them over the years, and I wanted a way to like display them. So it's like, this prompt was brought to you by Dr. Arthur Aaron. And then you click the next prompt button and it displays the next question. So I used HTML to add the text, buttons, and hyperlinks. I used CSS to position the elements on the page, add color to the button, and use a specific font style. And I used JavaScript to fetch each reflection question prompt from the backend database and add a simple animation when you click the next prompt button. So this is how sort of all of these things are coming together in a real application. This is something that I hear a lot from software or from designers, creatives. I hear it from everyone, like, oh, I can't code because I'm bad at math. And I think it's maybe a valid concern because a lot of computer science is very based in mathematics. But as I said before, I'm not a computer scientist. I didn't take like computer science classes. I did a boot camp. And I find that like having these mathematics skills just isn't as important as it used to be. So let's look really quick at, So we say like, I can't code because I'm bad at math, when in reality, a lot of the times we're going to be using something called open source software to solve hard problems. So you not being good at math isn't really a big problem because generally all of the hard like mathematical problems have been solved already by someone else, and you are going to be using their code in your application to solve the problem. This is the beauty of like this open source software community, where basically people can write software and then publish it to somewhere like GitHub, and you can go in then and pull in their code into your application and use it easily in your application. So for this example, this is a library on GitHub called React Anime, and it's a it does animations in the front end. So I used this library in my application to do the transitions. When you click the next prompt button, it does a little transition like a fade in and out. I didn't write that transition myself. I wanted to use someone else's library. I could have easily written that transition myself. I just didn't want to. And so I used this someone else's code, this library here, and I put it into my application and used it there. So that's a really good example of like a lot of things. If you're finding like, oh, I don't really want to have to write this whole component myself or write this piece myself, probably someone else already has. So what is more important than being good at math? Problem solving skills. I think this is the number one thing that software engineers do really well. And I think that everyone here probably does it pretty well, because as designers and creatives, you're already like solving hard problems. You just probably don't think about it in quite the same way as a software engineer, but I notice working with a lot of different engineers that a good software engineer is someone who can break down a big problem into smaller bite-sized problems. This was something that I had to get a lot better at, and I'm still like trying to get better at it. But yeah, so we'll go through like an exercise where it's like shows exactly what I mean by breaking a big problem down into smaller problems. But I just want to point out that, yeah, as designers and creatives, I think that the gap between like designer and software engineer just isn't that big when you think about like the fact that you're all already solving hard problems. Other skills and traits that are important in like being a software engineer: curiosity. And that's why I have this little octopus here. I love octopus, and I think they're really amazing, curious little creatures. Persistence is another one. So, picking yourself up when you had a bad day and, continuing to try to solve the problem. And a beginner's mindset. So knowing that learning any new skill is going to be hard and you're going to fail a lot. All right, let's talk briefly about project management for software projects. I added this because I think the way that software engineers manage their work is an important part of communicating with software engineers. So we have these terms: agile, scrum, sprints. What are we talking about? You may have heard these before. If you work closely with software engineers, you might hear these more often. You might have never heard of them before. That's okay. But basically, software engineers have a specific way that we manage our projects, and it's called agile. So we have the old way of managing projects, and this is called waterfall, where we kind of have like gather all the requirements, then design it and implement it. It's very linear, this process that we used to follow. We found that this process was really good for building roads, so like a traditional engineering process, but it was not great for building software. And we only knew that after a bunch of trial and error. And so the new way is more agile. So it is more cyclical. You find yourself like going through these cycles and repeating the cycle based on like what you're finding. So instead of being like really rigid and linear, we're more agile, and we follow like a cyclical design, test, development process. Let's talk about like how this came to be. So basically back in the 90s, there were a bunch of people writing software, and a lot of these people were like at companies like Microsoft, and they were basically taking like 3 years to release software. Like it was taking so long to release something, And they found that like by the time they were releasing it, like nothing worked as they expected. Users weren't having a good time using it. They had like a bunch of documentation. It was like users were expected to figure it out themselves by reading this like long list of like, here's how it works. And you should read this whole, 6-page article to know how it works. And users were not happy with that. So in 2001, a bunch of people, mostly dudes, I think it was probably all dudes actually, went to Utah and had this like conference where they were like, let's make software development process better. And they came up with this manifesto for agile software development. This is literally their website. This is a screenshot from their website. It's like agilemanifesto.org, and it has never been updated since 2001, I don't think. There's a bunch of people who have like signed it. But the basically this like chunk here in the middle, like valuing individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. So this is sort of the Agile manifesto, and it was just like a different way of thinking about managing software projects. And it was like, we're not doing waterfall anymore. Now we're all going to be Agile. Agile doesn't really give you any, like, it's just a philosophy. It doesn't give you an actual like structure for how to do anything. It's just like, oh, we like this better than waterfall. So then we have something called Scrum, and Scrum is basically like an actual manifestation of Agile project management. So there are other manifestations, like Kanban is another one. We'll talk about Scrum here just because it tends to be, I think, the most popular. But this is basically like the actual blueprint for how Agile could look in an organization. So it's more specific. So it involves splitting up the work into 2-week sprints. It could be like a 4-week sprint. It doesn't have to be 2 weeks, but a lot of the times it's a 2-week sprint. During each sprint, every day engineers meet for 10 to 15 minutes to discuss progress. And this meeting is called the Scrum or the stand-up. And then at the end of each sprint, so at the end of every 2 weeks, you should be releasing new software, which could include a new feature or bug fixes. So this is basically like, instead of releasing software every 3 years, we're releasing software every 2 weeks. And it allows us to like make progress incrementally and learn from our users. So if we're releasing software every 2 weeks, we can probably show it to a couple users, get their feedback, and then start the whole process over again based on that feedback. And this is where I think like design thinking processes and agile methodologies are really similar. So if you are familiar with the design thinking process, here's a little kind of diagram of like the pieces of design thinking. The design thinking process is cyclical, and so is the agile methodologies, where we're always like going back and repeating steps in a circle until we feel like we've really nailed the feature, we've really met user needs. And so design thinking is simply an approach to problem solving. It is focused on understanding people's needs and discovering the best solutions to meet those needs. Yes, and exactly, like updates and patches. So every time you're getting a software update or a patch, it's a result of like, finding out as users are using the software, like, oh, there's some bugs, we need to fix them. Yeah, so it's kind of like you do follow the waterfall process in those 2-week sprints. Yes, exactly. It's kind of like taking the waterfall process and chunking it into like little chunks and repeating it over and over, instead of like trying to gather requirements over the course of like 5 months, 6 months. All right, now let's go into how to start thinking like a software engineer. So how we're really like trying to get in the mindset of where a software engineer is and what they're thinking. We'll solve like a specific problem together and go through the steps. So the first thing you need to know is that software engineers think in terms of systems and components. What do I mean by that? Well, we never want to rewrite the same code twice. So for example, if I'm writing, say I'm writing an animation like that React anime library, what if I want to animate like not only the like prompts that come in, but I want to animate every time someone hovers on a button? Like there needs to be like an animation there. The goal would be to use the same animation code on like all of those elements and to make the code reusable. So that's one of the principles that I started to like realize in software engineering is like, oh, I need to like make this code that I'm writing usable in other contexts. So basically, we try to organize the code to make it reusable. We break it up into small chunks to separate concerns as much as possible. And we really like everything to be in its place. So when you are writing code, a lot of what you're doing is like getting on the same page if you're working with other software engineers about like, how do we organize this repository? So if there's files that are named a certain way or folders that are named a certain way, we want all of that to be consistent. And it doesn't really matter at the end of the day, as long as everyone's in agreement about what the conventions are. So yeah, I've seen code bases managed, all sorts of different ways. There's like sometimes conventions that people use, but it really just depends on the shared agreement between the people working in the code base. All right, so let's talk about solving a problem using this as an example. I think this is a nice example because it's a pretty simple app, but it illustrates a lot of these points. So using this as an example, let's talk about my coding process. Number one, make a to-do list of all the things that need to get done. You're probably thinking, yeah, I do that too. Okay, not that special. And I'll show you exactly what I mean in terms of like a software engineering context, because it isn't that different than anything else I've ever done, but a little bit more intricate. While I work through the to-do list, I write tests as I go. So tests are basically another part of the code that you're writing that is basically testing any code that you're writing. Like if I write a function that needs to do an animation, I could write a test alongside it that basically tests, is this animation doing what I think it's going to do? We won't really go into testing, but that's an important piece of the process. And then here is kind of the point where after I've got it working in some way, like, okay, it works. Maybe the code's really ugly, maybe it's messy. Then I would go back and make sure the code is clean and readable for my future self. That's really important. Like sometimes I go back and read code that I wrote and I'm like, who wrote this? This is awful. And it was me. And then I want to make it also readable for my teammates. So this is where I would actually start to do the making sure it's all componentized. Like I said before, how we're thinking in terms of systems and components. This is the step where I'm making that happen. And then the last step is optional. It's making the code more performant. So this is a step that I usually do only if we find that the code I wrote is somehow slowing down the application in a way that makes it like unusable for users, or they're complaining about something. Oftentimes it is the code that makes things run slow, and you would need to go back then and kind of rewrite what you did to make it more performant. And in this step, I probably would ask for help or like Google a lot, because yeah, optimization is something that is more of a computer sciencey type of concept. It's definitely like something anyone can learn, but I ask for help and I do a lot of Googling throughout this whole process. Let's talk about this step number one of making a to-do list of all the things that need to get done, and we'll go through this example together of like what I mean by that. Okay, so let's say that like I haven't made this application yet and I need to start like putting it together. So the task at hand is to fetch one reflection question prompt from the database and display it on the page. So this is where we're getting into actually like, how does something get from the back end to the front end? And it can feel a little intimidating, but I promise you we'll go through every step and we'll all understand it together by the end. So the task here is, this like pink box that I have around here, we need to get that from the database and display it on the front end. So my to-do list would probably look something like this. So I break up this task into smaller tasks. The first one is to read the documentation to make sure I understand how my application expects data to be accessed. Once again, we'll go through all of these steps one by one. Number two is in JavaScript, write a fetch request to get the data I need onto the front end. We'll go through it together. And then lastly is I need to create HTML tags for the prompt and the attribution. So this is where we're actually taking that data that we've gotten back and like putting it onto the page in HTML. All right, so we're back here in this like diagram of application architecture. And we're going to start by talking about databases. As we said before, databases are where we organize and persist data. Basically, databases are fancy Excel spreadsheets. And I feel like once I figured this out for myself, as someone who never really thought about databases before, like everything in the world, every application is storing all of this data in a fancy Excel spreadsheet. It has columns, it has rows, it has ID numbers for each like attribute. So on Twitter, you know, like if you write a tweet, that tweet is being stored somewhere in a database within Twitter. It's like attached to you as a user, like all of those connections are there in this database. So this was the actual like Google sheet that I made for my application, the reflection questions prompt. I stored everything in a Google sheet at first. And these were the columns, like prompt, attribution, and then the link. And then I basically like transferred all of it from the Google sheet into a database. And we'll talk about that a little bit. But for all intents and purposes, like this is what is backing that application. It's like a spreadsheet. So yeah, most of the data in the world is stored in databases, and databases provide structure and strict rules for how we store information. So one difference between like an Excel spreadsheet and an actual database is you can see here, like in any of these columns or rows, I could put like anything. I could put numbers, I could put text, but a database is going to be a lot more strict about what you can store in each cell. It's like if you say this cell should be like text, then you try to put a number there, it's going to be like, no, you can't do that. That's bad. So there are a lot more rules about like what databases can store, and you basically instruct the database for like, this value should be a number, or this value should be text. Yes, Airtable is a really good example of this. All right, so let's talk about this to-do list. Number one is to read the documentation to make sure I understand how my application expects to be accessed. So in this instance, I used Firebase Cloud Store, which is just a database solution. It's like a Google product. It's like anyone could go in and make an account to like make their own Google Cloud Store Firebase database. And I basically like read the documentation. So this is the Firebase documentation. And it straight up says like, here's how to add Firebase to your JavaScript project. I read through this and I was like, okay, I think I understand what's going on here. But a lot of software engineering is reading documentation. This is something that I had to get used to. It's like reading a lot of guides and tutorials for anything that I'm building. So I checked that off my to-do list. Now let's go to step 2, where in JavaScript, I need to write a fetch request to get the data I need onto the front end. The good news is that in my documentation, they had like a really straightforward example that was basically like, here's how to do it. Here's how to get your data on the front end from your database. And I was like, great, like I don't even have to think that hard about this because they gave me an example. If you find solutions that you feel like the documentation is really good and complete and comprehensive, like that for me is a big draw to why I would choose one solution over another. So that's a big part of software engineering, is like knowing why you chose a certain technology over another. That decision-making is important. But in general, I often opt for like the decision-making hierarchy. It's like, if the documentation is good, I'll choose that one over another because it's going to help me out so much in instances like this. So the code I ended up writing wasn't exactly this, but it looked a lot like this. I just had to like change some things to make sure I was like actually getting the right, rows and columns from my database instead of like San Francisco cities here. But after I like had written this JavaScript function on the front end, and I've actually successfully like grabbed a row from my database. So I pull in one row that I need to display this like reflection question and the prompt. The data that I'm going to get back on the front end is going to look something like this. This is called a JavaScript object, and it just has these like key value pairs. So the key is anything before the colon, the ID, and the value is like everything that comes after. So in this case, this is the number 28, it's the ID, it's like the row. And you can tell this looks like the rows and columns from my Excel spreadsheet. Like it matches up perfectly. So I got this data. Now what do I do with it? So this is going to move us on to the next step. We're going to create the HTML tags for the prompt and the attribution. So in this example, I have this data that came back in a JSON object, and now I have to create the HTML tags that are going to display this information. So in this case, I chose an H2 tag to display the prompt, a P tag to display like the citation, and then I found that there was this like actually like special citation tag that we could wrap the like attribution in. I was just Googling around like, how do I make an attribution in HTML? And I found this, and I thought it was like a useful tag to use. So you can see here how like this prompt, the key value is where I'm putting inside of these curly braces. So in this example, like obviously this HTML document, it looks like HTML, but it kind of has like variables in there instead of the actual like text. And something important to know is like, so this isn't actually HTML, although it looks like it. It's called JSX, and it's basically, I'm using on the front end, I'm using a front end framework called React. And we're not going to get so much into front end frameworks, but you may have heard of them before. There's the common ones are React, Vue, and Angular. And those are basically kind of libraries that you can use that make like the interoperability between JavaScript, HTML, and CSS a lot easier. So it's kind of like, it just makes things easier to manage your state on the front end. But for all intents and purposes, this looks like HTML, it acts like HTML. And so I think that's like important to see these concepts like map onto each other really like pretty one-to-one. So yeah, that is kind of my like example of how I think when I'm solving a problem. It's like I have a task that needs to be broken up, and I can solve this task kind of incrementally and make sure that I'm making progress as I go. If I didn't break up this task into like small chunks, I could get really stuck in like lost and not know, like, you know, I could like make the HTML tags, but if I can't get the data from the back end, then I'm already, you know, stuck. And I find that sometimes I get really overwhelmed by like the task at hand, and I forget like, oh, I just need to write out my to-do list and my tasks. All right, so here we have this question that like anytime you search like designers and code on the internet, there's like a bunch of articles that have this title. It's like, should designers learn to code? I think this like freaked me out for a long time as I was learning to code. Like, I don't know, should I? Like the answers were just strange. And I think I realized as I like actually started to learn to code that it was just the wrong question. So this is a quote from one of my favorite people on Twitter, who basically says like, should is one of those words that seems fairly innocuous, but can end up becoming a very invasive part of your thinking. I've spoken with dozens of people over the years who are utterly tyrannized by the shoulds in their heads. It's possible to get so caught up in what you think you should do that you lose all sense of what you really think, what you really feel, and what you really want. And I think that's just such a quote to like live by. Like you shouldn't do anything unless you're genuinely curious or like intrinsically motivated to do it. Don't let like this feeling of like, oh no, I should learn to code, I'm a designer, I should, like those shoulds will just trap you. Instead, I think you should learn to code if you're curious about it. Yes, El Luna's book about this, The Crossroads of Should and Must, that was totally like a motivation for me. Yeah, you should learn to code if you're curious, if you enjoy building and making things, and if you want to challenge yourself to do something new and difficult. Like that's really it. So I would love to know in the chat, like, what's one software idea that you have but you haven't like been able to build yet? One of mine is, oh, the Ideal Digital Planner. Yeah, that's great. Yeah. Directories, yeah. Those are really great. Oh yeah, custom proposal contract website. I like that. Oh, matching mentors with mentees, cool. Nice. I love all these ideas. Yeah, I think this is so great. Like it's really fun to see like how everyone has like their own context for like the software they'd like to build. Um, one app that I really want to build is like a birding flashcard app. I've gotten into birding in quarantine and I want to like get better at like testing myself on the birds that I think I should know. Pomodoro timer. I love Pomodoro timers. Nice. All right. So wrapping up here, where to start if you want to learn more. Free Code Camp has some really, really great resources and they're all free. They have one called Responsive Web Design. It's self-paced. I totally recommend it because you actually build projects in this course. And I think it's a really great way to get started. And then I also run a newsletter at designerswhocode.club. You can sign up and I kind of like explain software concepts with for designers and like learn together because I find that, like, as I said before, like having someone encouraging me was really the best and only way I was going to be successful in this field. And that's like what I hope to be for more designers and creatives, because I really do believe that the gap between design and engineering isn't that far, but it does take a little bit of like time and learning to get there. So my number one advice is to just start by learning one small thing and practice it, and then move on to the next thing. So I hope that this talk gave you a little bit of insight into like bridging this gap between designers and software engineers. And I'd love to now, open up the room to questions. We have about 15 minutes, and I know that there have been questions all throughout the chat, so I'm hoping to get to a lot of them. Yes, I know, it was fast. Okay, let's see. Oh, this is a great question, actually. What language do you need to know to be able to use the design software Framer? Okay, I was going to put this in the talk and I decided to not put it in, but if you've never heard of Framer, it is this software that's kind of like Figma, like it's a designing software and it's online. You can sign up for an account for free, and it's basically like Figma, but you're integrating more software engineering and coding concepts to use that program. So it's like you're starting to think like a software engineer as you're using that application. Like, and I think that's a really powerful way to like kind of start bridging this gap. To use Framer, I think it's built on React. So React as a front-end framework is going to be what you need to like start learning. But before that, even you're going to need to learn JavaScript because React is a JavaScript library. So totally recommend starting with JavaScript. And yeah, using Framer, going through different tutorials using Framer, I think it's a really great way to start like learning how even like CSS layout stuff works, like from the design aspect to the actual like front end programming. Thanks for putting that link, yeah. After asking devs what languages they're using, what's the best way to understand what limitations there are? This is a really good question. First of all, yes, asking devs what languages they're using, communicating more with devs. They're gonna love that. They're gonna love talking about the languages with you, probably. I mean, it depends on like the context, but I know the software engineers at my job would love for anyone to just be like, tell me about the limitations of this language. They would talk for hours at you. You can obviously also Google a question like that. I think there's probably going to be some pretty good answers. Yeah, a lot of it, like for example, we use Python a lot at my company, and in some ways it's like a really great language. It's really like easy to get up and running. So I teach girls who code courses to like middle school and high school girls, and I start them off learning Python. But it does have some like limitations in terms of like it's not strongly typed. So for example, it's like that's kind of a computer science topic, but there are some big limitations there that software engineers will have like really strong opinions on. Okay, yeah. Any difference between a front-end web developer and front-end software engineer? I don't think so. There's lots of terms, there's lots of like titles out there. And I think it kind of gets a little confusing, like front-end developer, front-end software engineer, like, I don't think there's really much of a difference. It's just a different word. Yes, I will put up the slide that was of the HTML and CSS. See, it's pretty far back here. Okay, here we go. What do you think of Webflow? I haven't used Webflow, but I want to. Yeah, I'm interested to learn more. It seems kind of like a similar thing like Framer, and it like has more coding, like front-end web development concepts like in that like user interface. So it's sort of like starting to introduce you to thinking like a programmer in a way that you might like, but it's more like a Squarespace, like drag and drop still, but it's like starting to get you on that path to like thinking more about like a front end, how a front end engineer would solve problems. Did you have to do a coding test when you applied to your job? Yes. This is probably like the most intimidating part of applying for software engineering jobs, is that they usually make you do a technical assessment. I still get really nervous about this stuff, and I've been running, like at my company now, I run the coding assessments. Like I do the interviews with candidates, and like all I try to do is make them feel like as calm and like comfortable as possible, because I know how scary it is. I did have to do a coding test. It was nerve-wracking, but at the end of the day, I think it was like, I wasn't, yeah, I think if it's framed as like, they're not like testing you, but it's like you're working together and they're kind of judging how good you are at working with them, that's a better way of thinking about it. So I've definitely like not moved people forward in the interview process if I found that they were like too difficult, even in this like hour-long session to work with. Like if they were interrupting me or like not listening to my suggestions, like I'm trying to help you. I genuinely trying to make everyone successful. So I definitely look for companies where you feel like the interview process feels more like collaborative like that. And it's just like going to be a better fit no matter what. What bootcamp did you take? I took a full stack web development bootcamp just in my town. So it's like run by my community college, and I was actually able to get it paid for with like federal grant money. So that was awesome. There's usually some like money available, and if you were like in a smallish town, it's kind of a bonus. Any things you wish designers did in handoffs? This is a hard question for me to ask because I am the designer and the developer, so I don't know. I feel like I like eliminate a lot of the like middle process part, but I did on Twitter see the other day like this, just a screenshot of this like designer handing off a design to a developer, and she had like really like gone out of her way to like annotate like the spacing between this thing should be this, you know, these many pixels, the spacing here, you know, like I felt like that was awesome. Like to have everything so detailed in a user interface, like laid out for me as a developer, like would be amazing to have that level of like detail. Yeah, I thought that was really nice. There's a project I want to do that requires C++. Knowing that's a bit advanced, should I get started on easier languages or dive right into complicated languages to at least get started? That's a good question. Yeah, I mean, C++ is definitely like harder, but at the same time, I think like starting with that isn't a bad idea. Like if I find that the biggest thing for me is like the best way for me to learn is to like want to complete a project, because if I care about the project, I'll write the code, I'll figure out the code part. So I'd say go with C++ and like see what happens, because also like you don't know any different between like what's an easier language and what's a harder language. Like it's all going to be hard. So I kind of just go with C++. As an engineer, is there anything you think engineers could benefit from in a similar way from the field of design? I mean, yeah, I think like engineers could totally get a lot better about like caring about users, I think is a big one. Like that empathy piece, I find sometimes like isn't there, which is weird. But I think like involving engineers earlier on in the design process, I found has been helpful. So I invite my engineers to user interviews that I do. Like I invite one of them at a time, and I feel like that's really helpful to like start creating this like, you know, when they're building a feature, they're like, oh, I remember that this user talked about this, and it like closes the loop a little bit more. I think engineers could obviously learn like the basics of design, and like it would help a lot in the whole process. There are some courses out there I've seen that are like designed for developers, and I think those are going to be like really useful as well. This question about like, can you talk more about Framer versus Figma? Won't that be harder to collaborate with other designers who don't code? This is something that I've thought about because the other designer that I work with also codes. So it's like, that's easy, you know, like we're both on the same page. I feel like it would probably take, there'd be a learning curve there where like your whole team would kind of have to be on board with using Framer. And that is a big lift. I realize that. So yeah, it'd have to be like more strategic in the way like you introduce it, and probably be a slow like buy-in process. Yeah, I started to read this. There's a InVision is a like design company that publishes a lot of really great resources, and they have a book, like an ebook and audiobook. I listened to the audiobook recently, and it's called Design Engineering. And that's sort of where I realized like there is this emerging field that is like designers who code. It's just not quite, I think it's yeah, it's really emerging. And so basically I highly recommend like listening to that audiobook or reading the ebook. And it talks about like how to start like advocating for like design engineering at your organization. And I think that could be a really good place to start if you're like, maybe I want to start using Framer instead of Figma at my company to like start learning this like programming concepts. Yeah, book title. I think it's just called, what is it? Design Engineering. And it's free online. How similar are Framer and Adobe XD? They're very different actually. So Adobe XD, I think, and Figma are pretty similar, where you're still in this like design space. You're thinking in terms of like pixels. You are starting to think in terms of like layout and like constraints. If you use like in Figma or Adobe XD, there's like, you know, the columns where when you like make a design collapse for like mobile devices, you're starting to think in terms of like a front-end software developer. I think Framer just takes it one step further, where you're actually learning like CSS concepts like Flexbox and like all of these layout things that like front-end developers think about, but like Figma and Adobe XD like mask that, so you're not thinking about it. A lot of the times it's like just words, like concepts and words that you are already thinking of as a designer. You just don't know the right word that like a developer is thinking of. That's what I'm finding. Yeah. Are you building consumer or enterprise software products? Technically, the products I build are enterprise. Yes, we have the products I build are products I build are for like data scientists who work within enterprise companies. They're very technical products. They're like, if you're familiar with like ArcGIS or desktop like geospatial software, that's the kind of software I've been building. What is the best way for a designer to communicate animations to the developer? Oh my gosh, this is a hard one. Yeah, it's hard. I think like Figma does have these sort of like, you'd have to do a prototype in Figma. In Framer, you're actually like using, like, you can code animations, or at least like more easily, add an animation to that prototype. So I do think in that regard, you're going to have to learn like the prototyping tools in either like Figma or Adobe XD or Framer. Yes, I will send out the recording. We'll send out the recording to everyone who attended, so you will be able to have it. I have a question here that was from earlier about leveraging Storybook and Figma to make collaborating with devs more productive. Yes, I think that goes directly. So Storybook is a like sort of a software that you can use to like build components on the front end, and just like you're just building the components. So it's like just kind of like the CSS and HTML and like the interaction. That is a really cool tool that I've used, and I'd highly recommend. Yeah, I think Storybook is a great like design engineering concept. So from that book, Design Engineering by Envision, if you can like dip your toes into Storybook as a way to like start learning to code, I think that's a really good idea. Thank you so much, everyone. We're at time, so I want to be respectful. But I really appreciate you all being here. And yeah, I'll send out everything so you have the slides and the recording to review later. Yeah, and I hope to see you all soon. Thanks so much.
Samantha, that was great. Thank you so much for sharing your skills with our community.
Yeah, no problem.
And as Samantha said, we'll make sure you have all of those resources in your inbox in 24 hours. So thanks for coming, everybody. Thanks for spending a bit of your Saturday with us, and have a great weekend. We'll see you again.
Bye, y'all.